So this is part 3 of the Chapter 8 study guide. So let's read the problem for number 10. So it says, use a p-value method to test the given hypothesis. Assume that the samples are independent and that they have been, randomly selected. Identify the null, the alternative, test statistics, p-value, and conclusion about the null hypothesis. So here's the situation. A marketing survey involves product recognition in New York and California. Of 558 New Yorkers surveyed, 193 knew the product, while 196 out of the 614 Californians knew the product. At the 0.05 significance level, test the claim that the recognition rates are the same in both states. All right, so the first thing we need to decide is what are we dealing with? Are we dealing with two proportions, two means independent, or two means dependent? So in this case, because we have numbers of people who knew the product versus out of how many people total, that looks like we're dealing with a proportion. We're looking at a percentage of people. So this is actually two proportions. So that's the first thing we need to identify, that this is two proportions. So this problem is a problem that is going to be similar to a problem that is a non-multiple choice part of your exam. So on the exam, you're going to be given instructions like this. So it's part A says, write the claim in symbolic form. That's what we're going to do here. Identify the null and the alternative hypothesis. That's where we're going to put the answers here. Calculate the test statistics right here. Calculate the p-value. And then the last question, decide whether to reject or fail to reject the null hypothesis. So you're going to need to circle one of these answers. All right, so once we determine that this is two proportions, let's identify the relevant values. So 558, that's the number of people in the first sample. 193, that's x sub 1, right? So n sub 1 is 558, x sub 1, 193. So n sub 2 and x sub 2, let's identify those. N sub 2 are the total number of Californians, which were the number of people in the second sample, so 614. And then x sub 2 would be 196. All right, so once we have those, and we know we're dealing with two proportions, let's go back to our diagram. Hypothesis testing, two samples, two proportions, right? Everything should be in P sub 1 versus P sub 2, meaning the claim should have these two notations, and the alternative in the null as well. And then we're going to use two prop z tests to test the claim. All right, so let's go back to the problem. Sorry, right here. So the claim, because we're dealing with two proportions, it is a statement regarding P sub 1 versus P sub 2. So the claim is that the recognition rates are the same in both states. So P sub 1 and P sub 2 represents the proportion of those who recognize the product in New York and versus California. So if the claim is that they're the same, the claim is P sub 1 is equal to P sub 2. The null is always a statement of equality, so P sub 1 equals P sub 2. The alternative is either the same as the claim or the opposite of the claim. So in this case, because the claim contains an equal sign, the alternative is not equal. All right, so once we have that, we're going to use two prop z tests. So let's load up the calculator. So two prop z tests, go to stat, go to tests, two prop z tests. X sub 1 is 193, n sub 1 558, x sub 2 196, and then N sub 2 614. This right here is the alternative. So the alternative hypothesis is not equal, contains a not equal sign. All right, so calculate. So this is the test statistic. This is the p-value. So let's write those values down. Please on the test, if you guys can follow the instructions. So the test statistic, we're going to round to 2 decimal places. P-value, we're going to round to 4 decimal places. So here we have 0.97, and the p-value would be 0.3331. Right, so last step is we're going to compare the p-value to alpha. Alpha is 0.05. So over here, alpha is 0.05. So the p-value compared to alpha p-value is greater than alpha, which means we failed to reject the null. Anytime the p-value is greater than alpha, we failed to reject the null. So don't forget to circle that. All right, so next problem. So problem number 11 is very similar in that it's a non-multiple choice question. So here I'm just going to go straight into reading this, and we're going to determine whether it's two proportions, two means dependent, or two means independent. So it says a researcher wishes to determine whether people with high blood pressure can reduce their blood pressure measured in milligrams Hg by following a particular diet. Use a significance level of 0.01 to test the claim that the treatment group is from a population with a smaller mean than the controlled group. Use a traditional method of hypothesis testing. You can ignore that. That's not going to be on the test. Just talking about the traditional method. We're going to use a p-value method. So in this case, sample 1 is the treatment group, sample 2 is the control group. And we have to decide what parameters are we dealing with. Is it two proportions, two means independent, or two means dependent? So in this case, because we're looking for the claim involves a mean, right? It says the mean is smaller for the treatment group versus the control group. We're dealing with two means. It's independent because we have a treatment group versus a control group. And there's no relationship between people in both groups, not that we know of, right? It's not like they're husband and wives or they're twins or anything like that. So the data are not matched. All right, so in that case, we're dealing with two means independent. So let's go back to our little diagram. Hypothesis testing for two samples, two means independent. Our claim and our null and alternative are going to contain these two notations, mu sub 1 versus mu sub 2. And we're going to use this function, 2samp t-test. Okay, so back to our claim. The claim is that the treatment group has a smaller mean than the control group. So mu sub 1 compared to mu sub 2, where mu sub 1 is the mean blood pressure for the treatment group, and then mu sub 2 is the mean blood pressure for the control group. The first group, the treatment group, is smaller, right? That's according to the claim. So mu sub 1 is less than mu sub 2. The null is always that there's no change, so which means it's equal. It's always an equal sign. The alternative, in this case, because the claim contains a less than sign, it's the same as a claim. All right, so once we have that, we're going to use, again, 2samp t-tests. So let's go to stat, go to tests, 2samp t-tests. We're not given data. These are statistics, so we're going to go to stat. X bar sub 1 is 189.1. S sub 1 is 38.7. N sub 1 is 35. And again, that's from the treatment group. So the control group is all the sub 2 stuff. X sub 2, 203.7. S sub 2 is 39.2. And then N sub 2 is 28. This is the alternative. The alternative contains a less than sign, so we're going to highlight that and press enter. Pooled, we're always going to say no. Just leave it as no. Calculate. This is the test statistic. This is the p-value. Again, please follow the round off instructions. For the test statistics, 2 decimal places, p-value 4 decimal places. So let's write those down. So the test statistic is t equals negative 1.48. The p-value is 0.0725. And finally, make a conclusion. We're going to compare the p-value to alpha. Alpha is 0.01, right? Significance level is 0.01. P-value is greater than alpha. This value here is greater than 0.01, which means we fail to reject the null. Anytime the p-value is greater than alpha, we fail to reject the null. All right, so again, a lot to cover, lots that we covered. If there's any questions, let me know.